Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this Center Stage presentation brought to you by AWS and Datadog. My name is Cody, and welcome back to Techstrong Learning. We have an exciting program ahead, but before we dive into things, I have just a couple of notes I'd like to review with you. First of all, we are recording our session today. So if you happen to miss any of our conversation, if you'd like to watch again at a later time, or if you'd like to share this with your team, you will be receiving the recording shortly after we conclude this live session today. Now, if you'd like to engage with us, and we've engineered this to be pretty interactive today, we do want you to engage with us using the chat tab on the right side of your screen. So when you find that chat tab, I'd like you to let us know from where in the world you're joining us from today. Additionally, we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So be sure to send in your chats and, of course, fill out our post-webinar survey. All of those will qualify you for the giveaway. And at the end of our program, we have a QR code on our presentation. If you sign up for a Datadog demo, one of you will be a lucky recipient of a limited edition Datadog backpack. So keep an eye out for that, and I'll remind you when that time comes. So today we are diving into the AWS Serverless Developer experience, and I'm joined by a wonderful panel of speakers here. We've got Steve Kendricks, Senior Manager of Product Management at ECS. Steve, thanks for joining us today.
Happy to be here.
We've also got David Nassi, Head of PM Lambda at AWS. David, thanks so much for joining us today.
Thanks for having me.
We also have Maxime David, Software Engineer for Serverless at Datadog. And Maxime is going to be leading one of our breakout rooms here in about 15 or so minutes. So more details to come on that whenever we are looking to split off into our 2 different rooms. So Maxime, thank you so much for joining us.
Hi, everyone. Thanks for having me.
And leading our panel today is Sumita Mehta, Product Manager for Serverless at Datadog. Sumita, thank you so much for being here with us today.
Yeah, absolutely. I'm really excited about everything we're going to be talking about today.
Well, perfect. Sumita, you want to go ahead and take it from here?
Sure. Let's get started. Awesome. Okay, so I want to say thank you, everyone, for joining us today for our webinar. I appreciate, everyone taking the time to learn more about how Datadog and AWS can help you optimize your serverless workloads in the cloud. But before we kind of jump into our discussion and our demo, we do want to share a little bit more about how Datadog can help you observe your serverless applications in AWS and how we work better together. So when it comes to observability and challenges when it comes to deploying resources in the cloud, there are a few main challenges that we see a lot of teams face when they get started in their cloud journey. One, there's a huge lack of visibility in complex cloud architecture. So you have organizations that are on-prem, hybrid, using multiple clouds at the same time. So managing all of these different containers, serverless workloads, can get quite challenging. We also notice that a lot of teams can be siloed. So, using different tools, DevOps and SRE teams are kind of manually forced to correlate a lot of data spanning multiple teams. It can get quite overwhelming, and it can be very hard to streamline, say, like alerts or data coming in from different sources. Scaling is also a huge challenge that we see teams face. So, for example, if you have a lot of data coming in from multiple sources, as your team grows, the amount of data that's coming in also gets, scales with your organization. And keeping up with all of that data and, managing the efficiency of querying all that data can get difficult. And finally, there's a lot of overhead costs that comes from managing multiple tools that can, take a toll on a lot of DevOps and SRE teams. So Datadog's mission here is very simple. We want to create a single unified platform for your observability and security needs. So you're not kind of jumping all over the place when it comes to monitoring your applications in the cloud. And more importantly, we want to have that end-to-end visibility on a single unified platform. That means we have all of the different services that you might be monitoring, powered by shared services, AI, and that includes infra monitoring, APM, real user monitoring, so you can get end-to-end visibility on what's going on in your application. When it comes to AWS and monitoring AWS services, Datadog takes metrics, logs, and traces from anywhere from your business transactions, the private cloud, on-prem, and it aggregates it into dashboards and the app view in an opinionated way to lend its best practices to developers. So, for example, we have more than 100 AWS integrations for services such as ECS, EC2, Lambda, Fargate, and more. And we also have our own agent and Lambda extension that can be used to get real-time monitoring for these services that can help developers troubleshoot much faster. So we actually just came out of reInvent a few weeks ago, and I do want to talk a little bit about some exciting new features that have been launched over the past few weeks. On the Datadog side, we launched Lambda Threat Detection, which helps you see any Lambdas that might be under attack. On the AWS Lambda side, the team announced the ability for Lambdas to scale 12 times faster. So if you can scale by 1,000 concurrent executions every 10 seconds until the aggregate concurrency reaches the account's concurrency limit. On the Datadog side, we've been leaning a lot more into open source. So we announced OTel API support within our tracers, as well as W3C trace propagation. And finally, as we kind of expand into other serverless workload monitoring, we also announced the ability to see your step functions visually and the execution throughout that step function. So we're going to start talking a little bit more about one, observability, and two, having a roundtable discussion. So you actually have two options here. You can either stay in this main room, and me, Steve, and David will be having a conversation about serverless, the landscape, best practices, or you can join the breakout room where we'll be talking about, where Maxime will be talking about an interactive demo and how you can monitor your serverless workloads in the cloud. Great. So just to kick it off, David and Steve, I think, serverless is a pretty loaded term. So I'd love to hear what serverless means more to your team at AWS. Customers are really excited about the promise of serverless, even back when it was introduced a few years ago. So yeah, I'd love to hear a little bit more about your thoughts there.
Yeah, I can start us off. First of all, thank you, Sumita. Thank you, Datadog team, for having us here. I'd love to talk to joint customers about serverless and all things as loaded as that term is, as you said. And it's funny because at AWS, when we use the word serverless, customers very often ask us the same thing, like, okay, well, what do you mean? And it's for such a word that has the word server in it. We try to tell customers that it is really not about the servers. It's not really about the compute. That's not really what the promise of serverless is, because the point of it is that you don't have to interact with it, or at least the interaction that you have with it is much less extensive than it would be in a non-serverless model, right? And so really what we think about when we think about the term and word serverless, or at least the way that we try and explain it to our customers when we talk to them about adopting it, is thinking about it as an operational model. And so that means in a world that is serverless, that AWS manages infrastructure for you, and you're shifting that responsibility for the compute, and then depending on the type of serverless model that you're working with, different aspects of all infrastructure, whether that be the networking or other sorts of capabilities, that compute and infrastructure is then managed by your cloud provider, AWS. And so when we start thinking about that, we really want customers to have the freedom to only think about applications and application capabilities and operating their applications along those lines, and not needing to worry about operational models that are heavily invested in managing, scaling, right-sizing infrastructure. And so customers are really responsive to that, as particularly we have customers that tell us that it really helps with agility and scale, but it also results in things like cost savings and greater agility on the customer side. Specifically, right, when you start thinking about the benefits that you get from serverless when AWS is managing resources for you, you get a lot of innovation on our side that gets delivered to you at either extremely low adoption cost to you or completely free and invisible. And David, do you want to talk a little bit about some of the economies of scale that our customers see?
Yeah, absolutely. So just to build on what Steve started talking about in terms of the economies of scale, I think one of the reasons serverless resonates so much with our customers is that they can delegate some of the most undifferentiated and yet most challenging problems in running distributed applications to AWS. So things like cluster operations, again, networking, many of the kind of low-level security controls, scale out and scale in, and all these capabilities. And that liberates customers to really work on what differentiates their business, right? And from that perspective, I think an interesting kind of inside-out perspective that we have is that as we build our roadmaps, our priority zero is always aspects of delivering better security, better resilience, better availability, and better scale for customers. So that is the top of mind for us and what we are continuously delivering and improving on customers' behalf. And then customers just benefit from that seamlessly without having to do anything. I think it's a very important property that customers can build on this foundation where AWS continuously improves the kind of the engine underneath to become better through time. So I think that is a very powerful property that customers are really loving with the promise of the serverless operational model.
Yeah, absolutely. And I think it's most exciting for like the application developers who really want to just, focus on building their application. And like you said, the undifferentiated, complicated parts being handled by AWS is really compelling. We, on the Datadog side, every year do some analysis on, serverless workloads to see, how developers are adopting serverless, the kind of data they're sending in. And in our last State of Serverless report, we actually saw that organizations running their serverless workloads on AWS rose by 3%. And over 70% of our customers are, running at least one serverless workload on AWS. So that's really exciting, I think, especially from where we started a few years ago. Customers are starting to use serverless for at least some, if not, a majority of their workloads. So Steve, I guess maybe I'll pass it back to you. Why do you think that we're seeing so much of this increase now?
Yeah, so there's a few reasons. I think one is that customers are hungry for agility. They are demanding more and more from AWS, like as we say, right, like we are trying to help customers write less code, configure less, and build faster. And I think customers are responsive to that. When you have the ability to truly, in many cases, just focus on what the application business logic is and what you're trying to do with that application, right? In terms of configuring, okay, rather than needing to worry about let me think about like all of my applications together. What are the compute type that I have? I need to right size it. I need to worry about patching. I need to worry about cluster maintenance and updates and upgrades across the whole fleet. What does it do by downtime, right? And you have teams of people that just work on those single problems, right? And that really kills agility, especially because when you think about the business value that is getting driven out of the company is not coming from that. It is coming from the applications that your developers are writing, right? And so you kind of have this idea of platform teams, and you have the idea of development teams, and sometimes different companies, those are the same thing, and sometimes they're very formally split. But either way, for both sides, we see that developers like the serverless model because they are then not asked to think about very complex infrastructure capabilities that otherwise they would not otherwise care about. And even the platform teams, again, say, well, this just makes it easier for me to deliver new value for my development teams because then, right, the uptime increases. We don't need to worry about patching and maintenance nearly as much. We don't need to worry about cost overruns and just be constantly having right-sizing programs, right? At least that's what customers tell us very often. We often say, I often get that comment about cluster upgrades and cluster maintenance. Very, very, very common for customers to come talking, looking for both Fargate and Lambda for help and understanding how they can reduce the amount of just overall maintenance that happens, right? So then what you also get in terms of just from the raw compute is very often for a lot of applications, better performance, more availability, automatic scaling, and improved security, right? Because a lot of the, right, when in the serverless model, that compute is sitting within AWS. And so a lot of the exposure that customers have is just automatically taken away, right? With AWS Fargate, we do not give you access. We do not give customers access to the underlying compute fabric, right, or to the kernel. So what that means is that basically there's a much reduced capability or chance for things to go wrong, right? Basically, the users only have the user space, and the security posture is greatly improved. And customers really respond to that. Again, it just has to go back to what is it that customers have to think about and manage when they are trying to just simply get an application up and running in the cloud. All of this, right, we often talk about the idea of total cost of ownership, or TCO. A lot of times that can be very vague or not necessarily super well defined when we start talking about anything in information technology. But customers do tell us really that they see real gains in overall cost of ownership because if for no other reason than just purely because of the human cost that goes in to managing and maintaining fleets of infrastructure, right? So basically just purely on that, right? The understanding of, okay, you only have to pay for what you use versus a very large amount of overhead managing and maintaining, right? Where really we see like the largest customers even seeing significant gains in cost of ownership. So for example, according to load customers who choose serverless services can reduce their TCO by up to 57% by shifting more of their operational overhead to AWS, right? So we just see really broad acceptance from our customers for serverless, right? There's over 1 million active customers that use Lambda each month. The number of tasks that run on ECS is well over 2 billion tasks launched per week, right? So these are some of the largest systems that support customers. And so basically, again, circling back to your earlier point, which is like, why are customers seeing or why are we seeing an increased adoption of serverless from our customers? It goes back to, right, increased agility, better performance, often better security model, very often for many applications, and overall, just if for no other reason than the human cost, reduced total cost of ownership.
Yeah, for sure. I mean, we're at Datadog seeing, like, I think over the past 2 years especially, a lot more adoption across even like the enterprise. Slowly you can kind of see that like thought leadership coming in, you know, like even like the biggest enterprises, like you said, are starting to see that, you know, the payout of adopting serverless workloads. You did mention a bit of Lambda and Fargate, Steve, and I guess now I'm going to pass it over to David. But I think the serverless landscape has definitely changed over, you know, the past few years. You know, as AWS keeps developing, the meaning of serverless and the services that you can use that are serverless has changed. So what do you think of that, David? Like what's really been evolving at AWS when you think about serverless?
Yeah, I guess I would like to frame that in terms of two key trends that we see at AWS in respect to serverless technologies. The first trend really is that serverless is becoming the new normal for building applications in uh, in a large swath of our customer when we talk to customers. So, it's interesting. When the first wave of cloud adoption was mostly customers moving existing applications from their data centers and just kind of leveraging the operational and the kind of cost benefits of the cloud more in general. But what we do see now is that customers are really keen to modernize their applications and whatever new applications they build to do so on a highly modernized stack that allows them to move much faster than traditional architectures. So this aspect of serverless being the new normal is something that we see where organizations mandate that for whatever use cases, the default starting point for you would be to build an application using services like ECS Fargate, Lambda, and some of the other serverless capabilities that AWS offers. And so we see organizations who have more traditional organizations or those that have been the non-cloud native, that those who had made the journey of moving from data centers to the cloud now have these approaches. And some examples of that are, just recent customers we've interacted with is Nationwide, Children's, for example, or Autodesk, who has this mandate of try to build everything new on a serverless stack. And they are seeing the agility benefits and are doubling down on the strategy. So that's one trend that I wanted to talk about. The second trend really is that within customer organizations, the maturity of adopting serverless is really increasing, and it is now a much more kind of established adoption pattern across many aspects, including observability, right, where many of our customers use capabilities of the Datadog offers and so forth. But it's a much more established pattern these days. And some of the properties of this is that customers are using serverless services side by side or part of same architectures, or choosing to build different applications on different sets of these services. So, for example, customers often pick ECS Fargate as the right tool for the job when they want to run containerized applications and to kind of get some of those benefits that Steve was talking about. And it is really suited for that kind of container modernization path that customers often go with. In turn, they do use Lambda side by side with Fargate for things like, if they really just want to run code without having to think about kind of scaling and so forth. And most of the infrastructure management is done by AWS. And so things like event-driven applications and synchronous request response applications are ones that are being built by customers with the use of Lambda. So it's really pervasiveness of adoption, maturity of the adoption path is really there right now, and it's kind of part of that new normal aspect that I was telling you about.
Yeah, and I guess speaking of Fargate, Steve, I know you're pretty heavily involved in the development of that product. Actually, again, we're going to drop in another fact here, but I think in 2022, when we did our study on Fargate and Lambda, we saw that 20% of our Lambda customers were also using ECS Fargate. I think this year, when I looked at that data, we're at like 25%. So we're seeing that sort of like hybrid, workload kind of increase. And also I just want to hear a little bit more about the increase of container-based serverless adoption from your perspective.
Yeah. So yeah, that's a really interesting thing that is you see, right? Like very often we have customers come to us and say, hey, which one should I use, right? Fargate or Lambda? And very often, right, it's, of course, the answer with anything in AWS is it depends, first of all. Then second of all, it's often, well, both. Like what exactly are you trying to do, right? And so we do see, you're right, we do see a large number of customers that are using both Lambda and Fargate, and that just depends on either the particular performance characteristics or the certain business logic of the application, or very often the same application or set of applications will just use both in different modes for different things, right? And so it's very actually commonplace, even internally inside AWS for our own internal services, because in AWS, right, we use our own products to build our own services. And so inside AWS for services to use both internally as well. And so just to talk a little bit more about the containerized serverless, right, or Fargate in particular, we view Fargate as the way for customers to really bring a traditional concept of building applications into the cloud, and then get that set up and running, right, in a serverless model with a container. And you can also definitely do like what you've heard more like the modern application way, definitely, as well as Fargate. But a lot of customers tell us that's that first entry point is getting that into a container and then adopting it, and you do not have to significantly re-artifact your application in order to get it up and running and achieve the benefits of serverless. And so customers tell us that's really powerful for them, especially then it buys them time and builds them time to then, if they decide then to further modernize, then they can go from there, and they do not need to, and they're already up and running on AWS in a serverless environment, so they're familiar with it and they understand the constraints. So that is that, and we also definitely have customers who are just building net new applications, or who, as they choose to migrate, they then re-artifact. So that still is very possible with Fargate as well. But customers do tell us they like that idea of, I can just move that application into a serverless serverless environment without having to do significant rework. So the idea of, right, like again, with Lambda and Fargate is like both solutions can be used for most applications, right? And most applications can be doing there is just, again, it goes back into, okay, well, what are the performance characteristics that you want? Many of our customers' compute workloads are stateless and run on ECS Fargate. Sometimes they need to run other things, right, like in terms of different applications, and they maybe they move into EC2 first, and then they move into Fargate. So there's definitely a lot of options in AWS, right? And like I would say that in terms of containers overall, ECS is the most popular entry point for container customers into AWS. So over 65% of all new containers customers start with ECS. And if you take a look at those, right, obviously a very large portion of those customers are starting with AWS Fargate, just because of the ease of use of getting set up and started. So customers such as Autodesk are choosing ECS Fargate as their preferred compute platform to simplify operations and improve security and agility. Right, like Autodesk has improved performance of long-running hydraulic modeling simulations using AWS Fargate, and in many cases boosting performance by up to 50%. And Autodesk was able to minimize like operational overhead, improve availability and security for their applications. Right, so there is a pretty big trend just within containers towards serverless, especially when you think about it from the Elastic Container Service side, which is AWS's opinionated container orchestrator, where we provide the best capabilities of what AWS has to offer, and we try to provide super deep opinionated integrations that allow customers to double down on the benefits of fully managed services and serverless in general. So around this time last year, we launched ECS Service Connect. What Service Connect allows you to do is it simplifies service discovery connectivity and traffic observability for ECS. So it helps customers build applications by not, right? So basically, right, what customers have told us is that for modern applications, very often what you need to do for setting up connectivity to each other is to adopt something like a service mesh. Service meshes can be quite difficult to adopt. They can be difficult to set up and manage, and it really requires specific expertise. So in building Service Connect, right on top of Fargate, what we allow customers to do is get that insight of AWS's opinion, not just for the compute infrastructure, but also allow us to offer opinionation into how a service mesh and service discovery should work. So customers can use Service Connect to basically just say, hey, here's a logical name for service endpoints, and use them in the client applications to connect to dependencies. Super easy. ECS will help set up and manage that for you. It'll send traffic to healthy endpoints, and then obviously provide traffic telemetry for customers, right? So it really helps that setup. And always when we talk about containerized applications, we talk about, right, what is the infrastructure that it's running on, but then also how do you monitor and observe what's going on inside the container? How do you monitor and observe the compute resources that you're using? Because again, as we said before, right, like that operational model of understanding what the application is doing is still really critical. And so the idea is, right, you need to be able to monitor what's happening, and we really try to provide customers with the capabilities to observe what they need. So that monitoring and observability is still really critical as we move forward. But yeah, so generally customers, I would say, just to summarize what I was talking about, right, it goes into the idea of just lifting and moving current applications. If you want to refactor, you can do that super easily, but it is ideal for getting running with a more traditional architecture in a serverless model.
Yeah, that makes a lot of sense. I think the containerized aspect definitely lets you kind of like, you see that like, oh, we can just take what we already have and just put it into Fargate, like you said, teams can get much more agile when they do that. And so you kind of talk a little bit about the use cases for Fargate. I want to also talk a little bit about the use case, or if there's like certain use cases just generally that are better built for serverless workloads. And maybe David, I might pass this on to you. I'd love to learn a little bit more about how AWS kind of suggests whether apps are good, or apps or services are a good fit for the serverless workload model.
Yeah, absolutely. So I guess where I would start is, if you think about modern applications and the key properties that they have, is that we live in a world that is very rich in data, and applications constantly have to process and analyze and work with large volumes of data, and that volume keeps growing. And so all of our applications are such that need to be supportive of very data-rich kind of use cases, right? And if we think about data and how systems and end users, for example, generate data, we can think about that as essentially as events. And so most modern applications that we see customers are building have this property of being data-rich and essentially event-driven. And event-driven applications is not a new concept. But within AWS, with our rich portfolio of services, we allow customers to build those applications in an extremely agile way, both from time to market and also from kind of the maintenance of that. And so EDA applications, event-driven applications, are ones that have been traditionally a really good fit for kind of the AWS serverless portfolio, and Lambda specifically, due to supporting a very rich gallery of integrations with other AWS services is a really good fit for that based on what our customers are telling us, right? To that end, you have applications of that pattern across the board. Many kind of verticals for financial services, healthcare, just e-commerce, and also from kind of the scale of usage, right? Like, because the property of serverless architectures is such that your pricing, your cost essentially is based on your usage, then you can start something that is very small and grow to be very large, and your costs will grow with your business versus kind of the more provision model over there, right? So just an example of that, Taco Bell very recently, they built an event-driven order middleware solution where they use some of our services with EventBridge, step functions, and Lambda to build a completely net new applications that updates menu items in real time. And what we saw is that the team was able to iterate so quickly compared and relative to traditional approaches, where they built a prototype in just 2 weeks and then released that solution in a way that scales to millions of orders per hour into production environment in 2 months. So I think that kind of speaks volumes to the agility benefits that customers can have when they build, these data-rich, event-driven applications using our services, including Lambda.
Yeah, and I think customers, when they do this sort of like migration to serverless, I think when they come to us, they have like 3 big like pillars or questions that they have. They're like, okay, I'm moving to serverless. What do I need to know about performance? What do I need to know about cost? And what do I need to know about security? So I'd love to kind of go a little bit deeper into those 3 topics. And I'd like to start with performance because agility, I think you hit on it. Teams move a lot faster and there's lower TCO. But when it comes to performance, like, there is a level of abstraction that happens when you're running, Lambda or Fargate or any other serverless service. So how are customers using serverless to improve performance? And also, on top of that, how can customers also improve their serverless performance or think about serverless performance? I'm going to pass this one to you, Steve, if you want to jump in.
So at AWS, we are very, very focused on performance, especially when it comes to serverless, because so much of that, again, when it comes to infrastructure management, one of the trade-offs that you're making is that idea of, okay, well, now the compute capabilities over the other capabilities, but often we talk about compute, it is now abstracted away from you. And so then you do not necessarily have you're really trusting the cloud provider in AWS to create that value for you in terms of performance. Now, there are definitely things that you can do to improve performance for the application scale, but in terms of compute performance, we really hyper-focus on making sure that our serverless offerings are highly, highly performant, and obviously in many cases much more performant than you might otherwise be able to get, right? So that idea of being able to bring compute to you faster and faster is something that AWS really works on, right? So making sure that your applications and workloads are resilient to changing factors, including the workload demands that are on them, and making sure that you deeply understand the business requirements that you have in terms of like traffic that's expected over time is really important to getting the most out of serverless. And we try and give you those tools to configure those capabilities as much as possible. Right. But the good thing is that, again, as David mentioned earlier, you're also just taking advantage of AWS's innovations in compute, and very often just totally invisibly, totally free right? We have customers that will tell me, oh, actually, what did you do? I woke up and, all of a sudden, or like over the past 3 months, I saw that performance had increased and in terms of like the ability for startup time, right? It just seems to dramatically increase for us, and that benefit that customers have is very often just arrives totally free. And then there's other things that we do that are able to help you in terms of something that or at least make it easy to adopt. So if you think about the traditional containers model, and here I'm talking about AWS Fargate, right? We have the idea of like, okay, if you're not running on Fargate, you're running on EC2, right? What happens in a container model? So the idea is the task starts, right? We go and launch an EC2 instance for you, or you go into your account and launch an EC2 instance, right? And then you say, all right, let's run this container. The container gets pulled down from a registry, something like ECR. It gets loaded onto the host, and then the container, right, it can set up and serve traffic. One of the things that we've noticed in terms of application and specifically task startup times is that a very large portion of them is not necessarily the launching of the compute, although that is a significant portion. It's actually the image download time. And so that's one thing that we took a look at and thought about how can we make that faster for customers, especially in Fargate, where we are pulling down that image. And some of our customers have very large applications, right? Hundreds of megabytes to gigabytes in terms of size of their container image. And that getting constantly pulled down was adding startup time for our customers. And so earlier this year, we launched an open source, what we call a seekable OCI or SOCI, and that's SOCI. And so what SOCI does is it is a technology that allows customers to deploy and scale out faster by enabling containers to start without waiting for the entire container image to download. So basically, SOCI reduces wait up time by lazily loading in and saying, okay, right, what components of this container image are actually required for startup? Let's download those things and then lazily load back in the rest of the things that are required after running. And so that dramatically reduces startup time, especially, or for a lot of applications, obviously everything here is application dependent, right? Not all applications are the same, but for many applications, right, they only need a very small portion of the libraries and artifacts inside that container image to get started, right? So for example, using SOCI, Autodesk was able to improve container startup times by 50%. Flywire saw improvements of 60%, especially for larger container images. And again, of course, the larger the container image, the more benefit that you'll get from this. So I think it was for containers over 750 megabytes, they saw improvements of 60%. Virtuoso was able to spin up ECS tasks up to 40% faster using SOCI. And so those are things that we are trying, that's innovation that we are trying to drive in because we realize that customers are trusting us for that management of compute performance, right? And so in Lambda, we have the same thing, right? Lambda functions, and we talked a little bit about the innovation. One of the things that AWS has innovated into compute is Graviton, right? Our ARM architectures. And so we allow customers to take advantage of Graviton internal to our service, into our serverless offerings. So Lambda functions running on Graviton to deliver up to 34% better price performance when running on them, right? With them running on x86. And David, we also have just recently released something called SnapStart. Do you want to talk a little bit about SnapStart and what it does?
Yeah, absolutely. So SnapStart is a capability that we also released for Lambda at reInvent last year, which essentially eliminated what customers are familiar as cold starts for Java-based functions. And so that was just a capability that we enabled with no additional cost, and customers could just choose to use it and get that benefit out of the box over there. And there are deep levels of innovation that went into that also leverage some of the same distributed application concepts like lazy loading and caching of initialized code and so forth. But I will not go into kind of all of that there. But the end result is that customers just got a feature at no additional cost that delivered up to 10x improved startup performance for their functions. And so, again, like Steve mentioned, these are just innovations that we feel we can deliver within our serverless portfolio for customers to just pick and use without kind of thinking about mostly additional cost or versions or cluster operations or anything like that.
Yeah, it's great to see that AWS is like continuing to kind of innovate in that like space of performance. I think we hear this a lot. Cold starts, especially, customers want to make sure that their whatever consumer applications are running as efficiently as possible. We actually launched cold start tracing for a couple of runtimes as well, just to give customers more visibility into how they can better optimize things like cold starts that are, kind of an inherent part of using serverless. And the fact that AWS is also continuously improving the space is like very exciting to hear. I do want to talk a little bit more about, maybe we'll jump into security. I think we'll have a few minutes to talk about that. And then I think we'll jump into some best practices, pitfalls to avoid. But when we think about security, I guess, in terms of the serverless environment, is there anything different that like customers should be thinking about, Steve, when they move to Fargate, for example? They've been using a regular containerized environment. They want to move to Fargate or Lambda. What are some considerations customers should keep in mind?
Yeah. So with Fargate in particular, right, we say, or in serverless in general, we do think that there is a benefit in terms of the operational model and the security posture that customers are taking, right? So with Fargate in particular, we have a higher level of isolation than what than generally speaking that you would see from, for example, ECS on EC2, right? So for ECS on EC2, one of the benefits and promises of containers is that you can bin pack multiple different containers onto the same host, and that's awesome, right? And and there are various security controls that customers implement in order to make sure that the containers stay isolated from each other. With Fargate, it really is a purely isolated, 100% isolated from any other container, right? So for an ECS, right, that underlying compute platform is fully isolated away from all other users. And so it is just purely that task. It is running in its own space. And so that is a little bit of a different security posture that a lot of customers like and value, right? And so risk-conscious customers in the financial industry in particular, for example, are adopting Fargate, specifically looking for those highly secure workloads to run on it, right? A great example is Vanguard, who went this route to strengthen disaster recovery, security, scalability, and resiliency overall, and they really like that isolation model that Fargate provides. Overall, just in general, in terms of security, there's also a lot of other benefits, right? Infrastructure is ephemeral. It's only spun up on demand, right? And it's not really living in your account. And so we often have customers that will say, like, okay, what I like about it is that I know when the compute is gone, it's gone. I don't need to worry about it. It's not sitting around. Right, it is all in AWS's account. AWS provides controls to lock down access at an application code level, right? So like IAM-based roles, role-based authentication, code signing controls, other sorts of controls that we have that still give you the controls over the application and what the application can do and what the users can do. But again, that infrastructure is something that gets abstracted away. At the same time, it's still really important to know that that it is a shared responsibility model with AWS, right? And so, right, it is always a partnership between AWS and the customer in terms of making sure that, right, like although we are managing the infrastructure, we are managing the application, that application, right, is still maintained and monitored and by the owner, and that you are using the controls that we have, right? And so one thing that we have with customers is just making sure that we give them that control to secure their own environments.
Yeah, and I think that's a huge part of what our misconfigurations product at Datadog is really trying to help our customers, is how they can better, use that shared responsibility model with AWS to make sure they're, following all best practices. Let's maybe jump into, like every tech decision is kind of it's a trade-off. Every time you decide to move over to serverless, use a certain service, I think there's interesting questions that customers have to ask themselves and answer, around performance, cost, what considerations you should keep in mind. So maybe we can start with cost perspective. I think most of the does serverless involve better cost does it help customers save money? Like, how do we think through that question, David?
Yes, Sumedha, you did cut off there at the end, so could you just repeat your last sentence?
Absolutely. So I was talking about trade-offs that customers make when they move on, to have a tech decision. Sometimes a consideration is cost. And, we did talk about how serverless actually saves customers money. So I want to learn a little bit more about that. What are the cost benefits here? How do you best leverage serverless to give you the most cost benefits?
Yep, absolutely. So I think generally kind of the way to think about serverless architectures is that your costs become much more aligned with the actual usage of your applications. And so from that perspective, they become much more aligned with your kind of business volumes and potentially even kind of your revenues, right? If those applications are driving core aspects of the products that you as as an AWS customer kind of sell over there, right? So what that means is that when your kind of usage of your application is still small and nascent, your costs are commensurate to that. And as you grow and as your business grows and finds success and you have more customers and you have more business volumes, then it will grow kind of proportionally. Your infrastructure costs will grow proportionally. So I think that aspect is a really powerful one, because you don't need to make these really heavy kind of upfront thinking about I need to pre-provision or to think about when I need to scale out, I will have to do that in a radically different way when my application does become successful. So that's a really powerful kind of property over there. The other property is that engineering costs, engineers are the most precious resource within technical organizations. There's no doubt about it. It's really hard to find expertise in distributed applications and so forth. So, within serverless applications, a lot of that muck and undifferentiated parts of running applications are now delegated to AWS. So you get to, either have, less engineering resources applied to building out your, technical organization, or you're just, leveraging your engineers in a much more differentiated and way to build innovative features and capabilities for your product. So from that perspective, there was a study by Deloitte of how much savings customers are seeing, right? I think Steve mentioned that one as well. And so as you think at the broader kind of TCO level, customers are saving up to 57% on average when they move to the serverless operating model from their kind of more traditional way of building applications. So that's kind of some very interesting properties of using and leveraging serverless. Now, that still requires customers to be diligent about how they think about budgeting and costs. And some of these things do change from the more traditional approaches, right? Because you have to be set up your budgeting observability, like your cost observability, in a way that tracks all of your kind of resources and all of your kind of architectures over there, right? It's not just, hey, this is my kind of fixed size of architecture, right? So we do that. We help customers with that with some of the new capabilities that we launched at re:Invent with Cost Explorer that allows granular view of resources, like on a per function level, you can see your cost. And so that's been something that customers are looking to leverage, increasingly more.
Yeah, I think it's really great to see. I think that that responsibility is also shifting more towards the developers, as you deploy your Lambda function, or and you are benchmarking it and trying out certain different configurations. You can actually see how cost changes over time. And at Datadog, I think we've invested heavily in having that sort of view for you as a developer. So you dig into a Lambda function's metrics. You also have its, estimated cost. So, you are kind of responsible for making sure that you are trying to optimize that workload for your team. I know we have a couple of minutes left. Maybe we have 1 minute to talk about some pitfalls or some high-level pitfalls that maybe customers should try to avoid when getting into serverless, and then we'll have a little bit of time for questions. So I think that one I'm going to hand over to both of you. I don't know who wants to take that one. It's a pretty loaded question with not a lot of time, but that's what our Q&A is for as well.
Yeah, just very quickly, I'll hop in, and then let's Steve add if I missed anything. But at a high level, what I would say is that serverless services definitely allow you to delegate more to AWS, but you still own the responsibility. These are technical tools, right? And so you own and you are responsible for picking the right tool for the job and architecting things in a as you build those architectures in a well-architected way across various properties. And while that responsibility gets easier with serverless, it doesn't go away. And you can still have some pitfalls if you don't kind of think things through over there. And conversely, if you do, you're setting yourself up for success. So this role of platform teams thinking about architecture and enabling compute and applications, and development teams thinking about their architectures, that still remains, and teams need to think kind of deeply about those aspects. Steve, do you want to?
Yeah, it goes back into the idea of like making sure that it's right. Like I think we said this a few times, right? Like where serverless definitely reduces the operational overhead, but it's not replacing all of the operational responsibility. And so there still is that shared responsibility model of making sure, right, when AWS provides something, right, like you're also making sure that your application secure, that it is using the right resources. That changes. It's not completely gone. It makes it easier, but it still is there. And so customers do need to be aware that that operational model of serverless is a little bit of a new muscle. We think it's an easier muscle. We think it's a super valuable muscle, and it's more directly aligned to costs, and it's more directly aligned to business value for you. But still, at the same time, it still is something that makes that you should make sure that you're paying attention to.
So this is a public website where everyone can order pizza and track the status. And I have a backend here. So if I refresh, I can see all of the orders. So thank you so much. There's a lot of pizza orders. So that's great. This is a live demo. So maybe I can change the status. So I move every pizza to a prepared state. So you should be able to see that the status has been changed. As you can see on my screen, it has been changed to prepare. And maybe we don't want to wait much longer. So let's say all the pizza has been delivered. So it should change on your webpage as well. So this is a fully serverless application. We will talk a bit about how it's built and most importantly, or we can monitor this solution. So yeah, I see some pizza emoji. That's great. So yeah, that's it for the demo. Let's go back to our slide. So yeah, as I say, it's like 100% serverless architecture. And so the front end are hosted on S3, which is an Amazon service, which where you can host files. For instance, you can even start a web server. This is what you saw on the demo. Then when you order a pizza, it will trigger an API gateway, which will invoke a Lambda function. So we have Lambda function here. Lambda function is an event-driven service, so you need an event to wake up your Lambda function. In this case, it's going to be a message from a HTTP gateway. And this Lambda function, depending on which route you hit, and we will be back to that in a minute, will trigger some business code, such as order a pizza, change the status, list the pizza. So one Lambda function for every single feature. And for instance, when you order a pizza, it will actually take the pizza and store that into a DynamoDB, which is another AWS services to store data. So yeah, once again, this architecture is 100% serverless. The only code that I've deployed is on Lambda function, but Lambda function itself, it's not an application. You need an event, you need maybe a DB, so you can't monitor only Lambda function. You need to have like a global picture of what's happening in your application. So let me see if I have a question. Yeah, okay, all good. So yeah, this is the architecture. Buckets to host the file, a gateway to receive messages, a Lambda function to actually execute business logic, and finally a DB to store and retrieve the pizza. So let's have a look at what's happening. Oops, not here. On my AWS account. So I have a WebSocket gateway to send and receive messages. That's why it's like live when you saw on the web page the status flowing in. This is a message sent via a WebSocket. I have also a table. Let's go on the order. If I click on the tables, I have my order here. If I explore the table, let me refresh it. I can explore. So I have 30 pizza here. So the status, the pizza name, and the order ID. So this is my DynamoDB table. And finally, I have my functions. So 6 Lambda function, one for every feature. So to list the order, to connect to the gateway, to track the pizza, to disconnect, to change the status, and to order a pizza. So yeah, 6 Lambda function, 1 API gateway, and 2 different tables for DynamoDB. So what we want to do now is to instrument this application, and we want it to be codeless. So you don't need to actually add specific code into your Lambda function. This will be done automatically via npx commands. So we have different options to instrument your workload. It can be a CDK from AWS, CDK construct. It can be a serverless framework. If you're using the serverless framework, you can add a plugin to, at deploy time, add some environment variables, some layers, 1 layer for the tracer, 1 layer for the extension to monitor our Lambda function. Or you can use CLI, maybe in your CI/CD pipeline, maybe locally and in computer to do a test. So it's basically npx. You type Datadog CI. Then, and this command line tool is not only for serverless, it's for every pieces of Datadog. So we need to specify that we're dealing with Lambda and instrument. By doing this, we can pass some parameters such as the function regexp. In my account, I have like 452 function, but the function which are really interesting for our demo are prefixed with maxday demo ddog. So maybe I can say that I only want to monitor those Lambda function. I want to specify the region. Here I'm deploying an EU West 1, but obviously you can change that to your own region. And finally, we have 3 different tags. One is for service. So let's imagine you have like a multi-tenant application with a lot of different services. Maybe you want to scope your instrumentation with a specific tag, which is a service tag. This will be super helpful, super useful to detect and to tag your resource on the Datadog UI, so you can search for a specific service, for instance. You can also specify an environment. Here I'm on the dev environment, but you can have like staging, production, custom names. It's really up to you. But it's once again, it's to segregate your workload and to make sure that you're not mixing dev with production data. And finally, you can specify a version. This is really helpful when you want to monitor, let's say I have my function in V1, function in V2, what is the performance impact of having a new release, or just to compare two different versions. So one command to instrument everything. If I look at my Lambda function, what does it mean to have it instrumented? 2 layers has been added, one for the tracer and one for the extension. So a layer is basically a zip file uploaded to AWS that you can attach to your Lambda function. And in this extension, there is a binary, like an agent, which will inspect your request, add some metadata, and send data to Datadog. So once again, no code required in your Lambda function. It will be automatically done via CDK construct, the plugin, serverless framework plugin, or via the one command line tool that I've just shown you. So let's have a look at Datadog now. So this is Datadog UI. You can access via app Datadog HQ. And if we go to APM, as you can see, I have 3 services. So Pizza Demo, which is the combination of all Lambda function. I have my DynamoDB, and I have my gateway. So yeah, this is great because we only instrument Lambda function, but thanks to the requests coming in and coming out, we can infer that, oh, this request is coming from a gateway, and this request is going to a DynamoDB table. So that's done automatically for you. You don't need to do that. So you just need to instrument your Lambda, and the incoming and outgoing requests will be detected, and this will create services. So next, we can go to infrastructure and serverless. And here, remember, we tagged our services with a pizza demo. So everything is grouped under this pizza demo. If you have more services, this will be shown here. But this is a demo account. So if you want to sign up for free, you can replicate this exact same demo. So if we have a look at the pizza demo, we can see here that the API gateway has been detected as well. So Lambda function needs an event, and this event is coming from API gateway. It could be S3 bucket. When you put an image into a bucket, it will trigger a Lambda function. It can be when you insert something on DynamoDB, it can create an event that will wake up your Lambda function as well. So we detect a lot of different triggers, cron jobs as well, via event bridge. So yeah, we detect a lot of incoming triggers. So finally, let's click on maybe a function, this order function. So this is a side panel for the exact function. This is order and order. So first, what you can see here is a list of invocation. So over the past hour, we have 32 invocation, which makes sense because we have 30 pizza, and I did some tests just before the demo to make sure this is working. So yeah, we have our 32 invocation. First, you can see that there's a big spike at 11:10 on my time zone, which is basically when the demo has been happening. So you can see it's real time. You see the number of invocation. You can see the trigger as well. So Lambda needs a trigger. So this is here. You can see the duration of the Lambda function, and you can see the logs. So if I open a log, let's say this one, I can see that I have my start and end and report. So this is logs provided by AWS. But obviously, if I have a custom log in my Lambda function, let's say I order a pizza with order ID 36, pizza name, all the rest, the logs are tied to one invocation. So we have a strong correlation between invocation and logs are really tagged to one specific invocation. So this is really convenient to debug or to understand what's happening at an invocation level. So you have logs tied to your Lambda function. One cool feature is also the trace. So basically, a trace is the visualization, of what is happening during one invocation. So we know that it's coming from a gateway. So if we click on it, we can have the name of the gateway, the status code returned by this invocation, the URL detail. It's the Lambda function is written in JavaScript, so it's inferred via the payload. So you have a lot of different useful information here. This event goes from the gateway through the Lambda function. And this is a span. So a trace is compounded of spans. So every rectangle is a span. And the amount of span is one trace. So if we click on the pizza demo here, we have once again a lot of very useful information. Architecture of your Lambda function, call start duration 0 because it's not a call start here. You have the version of the instrumentation, the trigger, which is a gateway, and so on. You have a lot of different information here. And once again, this has been auto-detected for you, so nothing to worry about. And finally, we know that this Lambda function is going to a DynamoDB table via a put item. So put item is the SDK command to actually create an item on DynamoDB. So this span has been created for you. You can see the timing. So putting an item is 7 milliseconds. So this is fast. But obviously, this is really useful to understand where you spend the most time on your invocation. So if you have a 5 seconds or 2 minutes invocation, you can see the drill down here. So in my Lambda function, I spend 51%. In my DynamoDB, 5%. So this is really useful to really have a global picture of what is happening for one invocation. So this is a warm start invocation. It means that the Lambda function has been already running for some times, or the number of requests is super steady, so there is no need for bootstrapping a new instance of a Lambda function. But if we look at, let's say, if I want to filter maybe cold start only, this is when your Lambda function is starting for the first time. Let's say you have no traffic at all, and then you have a request to your Lambda function. This will trigger a cold start. Also, when you have a very steady workload, but suddenly you have a big spike of traffic, new instance of Lambda function will be spawned, and this will trigger a cold start. And we have a specific feature for cold start, which is cold start tracing. So what you can see here is really what is happening during a cold start. So during a cold start, we need to load the AWS SDK for DynamoDB and the gateway, for instance. So it's a lot of different spans, but if you really want to dive deep and really understand of what is happening during cold starts, you can see those spans and really understanding okay, DynamoDB is 579 milliseconds. Let's say I have another function which is not using DynamoDB. So if I see a DynamoDB spans, maybe I know that I've included some useless dependency, which will increase cold start duration. So you don't want to do that. So maybe you want to have a look at those cold start tracing to really understand what is going on when a Lambda function is starting. So this table is valid for every Lambda function. Let's say for a connection. So for every function, you have a list of invocation. You can filter by cold start. You can inspect the trace and so on. If you look at this, there is also a metric. So each invocation is generating some metrics, and we can catch that. So there is the init duration. So during cold start, the number of errors, you can see that there is no error here. But if we click on maybe disconnect, you can see that there is a lot of errors here. So let's dive into this metric stuff. So if we go to metrics, Explorer, if you type AWS Lambda, you can see by auto-completion that we are generating a lot of different metrics. So let's say I want to check for my invocation. This is the number of invocation, and obviously between 11:10 and 11:17 during the demo, we see a big spike of invocation. So this is the metric for every Lambda function or Lambda function combined. So maybe what we want to do is to group by, let's say, a function name. And if I zoom a bit, I can see that change status has been invoked 20 times, order has been invoked. Let's me group by the count. I can do max my function name. Function name, sorry. And I can do maybe bars. And if I zoom in this one, I can get rid of that. So let me refresh. If I zoom it, I can understand the total number of invocation here and what is the split between Lambda function. Obviously, you can create dashboard on this. You can create alerts. Let's say I want to be alerted when too many pizza are ordered or when too few pizza are ordered. So a metric is a really a good indicator of a lot of different stuff. So you can see invocation, but maybe I'm interested in, let's say, max memory used to see. So here we can do line. And we can see that max number of memory used is 184 megabytes. So this is really useful to calibrate your Lambda function, because when you deploy your Lambda function, you need to specify a memory size. So if you specify 128, that's not enough, and this will increase the call start duration or the duration. So by inspecting the max memory usage, it can help to fine tune the memory that you want to allocate to. So this is for metrics. We can also have a look at logs. If we have a look at logs, this is the view where all logs from all Lambda function are flowing. So this is great. Obviously, you can filter. You can filter by function name, for instance. You can filter by region. You can filter by a lot of different stuff, and you have, for instance, not function name, but let's say you can filter by RN as well. Oh, sorry, I need to remove this. You can filter by RN, which are auto-detected. You can filter by function name. Let's say I just want to see my log for the connect. So yeah, it's a view with filters. So you can apply a lot of different filters to understand what is happening. One very cool feature is also the group by pattern. So instead of having a look at one single line every time, maybe you want to detect patterns in your logs. Let's say you always have log A, B, C, D, and someday you have A and D. So something might be wrong. So we can go by pattern and see what is happening. So for instance, I can see 2 errors here, and it seems that DB client is not defined. So here you can see directly which file is responsible for that, which line number is in error, and maybe fix it and redeploy it. So that's very convenient, and we can see in this log that it's coming. If we click on this single line, we can see that it's coming from the demo Datadog dev disconnect. So it seems that this function seems to have an issue. And if we go back to the infra and serverless, we can see that the disconnection, every single invocation is in error. So there's a lot of way to detect those errors. You can see the metric here. You can detect it from logs. You can detect it from the trace as well. So if we open the trace, we can see like this this mark here that an error has been detected. And if you click on the error, now you can see that DB client is not defined. So yeah, you can detect an error from metrics, from log, from traces, yeah, from a lot of different places. There is also some insights. For instance, here you can see that a lot of our invocation are triggering a cold start. This is normal because our serverless application was totally down, and a lot of pizza orders were were triggered. So a lot of functions are actually in the cold start mode. Obviously, the longer you're running your application, the less cold start you will see. But that's a cool way to see. Maybe you have an error in your Lambda function, and your Lambda function is responding a lot, so it will create cold start. So if you see this kind of insight, maybe you want to have a closer look at that. Also, you can see errors here for disconnect. So it's a good trigger as well to see, oh, I need to investigate a bit more on this function. So that's it for the demo. Thank you so much. I just want to make sure that everyone has time to ask questions. So let me go through the chat. How does connectivity to DD works from Lambda? Do we need to make any change to our VOC to enable internet gateway? So the connection. Oh, thanks. Oh, that's a very cool Q&A. Thanks. So yeah, the connection is happening via HTTPS connection. So at the end of an invocation, or where we receive like a batch of invocation, we have a different mechanism to make sure that we do not flush one-to-one, one invocation to one flush. We can do batching, we can do periodical flush, and so on. This is happening through HTTPS between the agents in the layer and Datadog index. So if you have a VPC, you would need to configure that. We support also proxy. So if you have a proxy, you can specify the environment variable or via configuration that's DD proxy HTTP or DD proxy HTTPS to send data the way you want. But yeah, it's a HTTPS connection.
Awesome, Max. It looks like we've got a couple other questions over in that Q&A section. So I'll go ahead and just read it out for you.
Yeah.
What Amazon low-code or no-code services work well with AWS Lambda serverless? And if so, can you go into details about them?
Yeah, that's a very interesting question. So basically, Lambda needs an event to be triggered. So, and Lambda is, I don't have the number, but is supporting like a ton of events from AWS. So as long as the low-code or no-code is producing an event, your Lambda function can be invoked. So as I said, it can be when you put an object into S3, when you put an item into DynamoDB, HTTP request, for instance. So yeah, as long as the upstream services is firing an event that is supported by AWS, you can directly invoke your Lambda function. If not, maybe you will need a HTTP gateway to like do a webhook or something like that. So yeah, basically, if it's supporting, if it's supported out of the box by AWS, that's fine. You can read the event. If not, maybe you need to add a gateway or something to invoke your Lambda function.
Wonderful. Thanks, Max. I'll put up our next question. But after this learning experience, what resources or follow-up actions would you recommend for participants to continue their journey in serverless deployment?
Yeah, that's really interesting. What resource? Obviously, maybe Datadog documentation to see where you can fine-tune. This is like the default setup, which offer a lot of different options already. But maybe you want to capture the payload. This is also a feature that we support. We obfuscate some common data type that can be maybe a bit confidential, but you can add some regexp to make sure that we strip out. So we capture payload. We have a support also for ASM. ASM is the threat detection. So let's say it seems that the incoming payload to your Lambda function is a bit malicious. ASM can trigger an event in Datadog, and you can see that. So yeah, I would say the resource would be how to monitor your serverless application. Maybe make sure that your architecture for serverless makes sense for your use case. I'm a big fan of serverless, of course. A lot of different scenarios have let's say a good fit for serverless, but some may not. So yeah, make sure you're choosing the right technology. And yeah, once again, serverless is not only about Lambda. So make sure that you can check other services as well. AppRunner is a good AWS serverless workload as well if you want to deploy a container and just not only one Lambda function. So yeah, App Runner could be a good fit for serverless as well. So yeah, and you can go to serverlessland.com. It's a website led by AWS where you can contribute, of course. But it's a great resource to learn more about architecture, monitoring, best practices for serverless. So yeah, serverlessland.com. You can go there, and there's a ton of information there.
Awesome. It looks like we've got just a couple of questions left here in our question bank.
Yeah, we have time, so feel free to ask any question you want.
Absolutely. Looks like I accidentally just got rid of the question I was about to ask. So one moment. Let me jump to the next one before I go back and find it. I'll put it up on the screen. Lambda function tied to API gateway. Do you have specific details that AWS logs and such don't provide?
Do you have specific details that AWS logs and such don't provide? So I'm not entirely sure that I get the question. Do you mean what kind of information you can get from Datadog that you don't have in CloudWatch, or is that your question?
I'm more looking for, like, do you have special visualizations? Do you have, like, if I go to AWS and check my logs, I can check my logs there. This is a thing. Do you have special visualizations or special that, like, add benefit over the AWS logs?
Yeah, that's a good question. Obviously, you have CloudWatch log for a single function. What we offer here is, if we go back to logs, you're still seeing my screen. Yeah, okay. You can search your log across all Lambda function at once. We also have a pattern group. So let's say one Lambda function is invoking another one, and another one, maybe something is wrong between the three Lambda function. And if you look at individual logs, maybe you won't get that information. So having it's really like a single pane of glass. You have everything at one place instead of looking at multiple places. But yeah, if you're comfortable with CloudWatch, that's totally fine. Maybe for your use case, that's fine. But yeah, I believe logs in Datadog are really powerful for like having a global vision of what's happening. Also, if you want to, let's go back to the infra serverless. If you want to understand, maybe let's say you have a big spike of invocation or a big spike of init duration. Maybe you can have like a look at the correlation between logs for this specific invocation and this specific spike in metrics. Let's say the max memory used. I can see that there's a big spike of max memory use. I want to see the log specifically for one invocation that happened between 11:10 and 11:20. So maybe to search for those specific information, that's really helpful to have the log directly correlated to this specific invocation.
AJ, thanks for that clarification. Oh, Rick, go ahead.
Dashboard might be interesting as well if you have that in your demo account. I'm not sure if you have a whole lot in there.
Yeah, I'm not sure if no, I don't have a dashboard, but I think there's some default dashboards. Yeah,
so for API Gateway, I think there might be a dashboard. Oh, maybe not in your trial account, but
this is a trial account.
So the metrics for the services as a whole, and then also how they correlate and tie together, right? So if you're looking at something that's just a log, that's one piece of the puzzle. But if you're actually able to get runtime metrics in addition to the logs tied together the services, as Max said, it's really where it starts to kind of tie it all together, and you're not bouncing around from point to point through the different services.
Gotcha. That's exactly what I was looking for. Thanks.
All right. Well, everyone, it looks like our main room is ready for us to rejoin them. But I do want to encourage everyone to repost your question back in the main room, because we are going to be moving to a Q&A format over there. So I'm sorry, we do have to cut this just a little bit short, but let's go ahead and rejoin the rest of our group.
Yeah, I just want to say a big thanks for your interactivity during this demo. It was really cool to see those pizza order and the live discussion. So yeah, thank you so much.
Great. Well, with that, thank you so much for that great conversation. I know we have a few questions, a little bit of time to answer them. So Cody, I will hand it back over to you.
Awesome. Thank you, Samita. We have received a lot of questions, and so I do want to just let everyone know we will be going over time just a little bit. So thank you for sticking around with us, and we hope you choose us over your next meeting. So our first question comes in from Richard B. He says, it's nice to not manage servers, but that means someone else is. So what is the best approach for observing, monitoring, logging what OS, kernel, etc., and patch environment my app is running on and has run on historically? Let me go ahead and put this one up on the screen. It says, so that I know my current and historical security posture on serverless.
Yeah, I can take that from a Datadog perspective. I don't know if there's a answer from Steve and David as well. But on the Datadog side, this is a pretty common ask from customers. So we do have a product called CSM Pro that does show current and historical security posture for serverless compute. And then we also have CSM showing misconfigurations for Lambda functions. So that'll be based on compliance framework, identity and access, and just general misconfigurations. We can definitely send over some documentation on this, but I highly suggest looking into CSM Pro, Datadog, and that should work for serverless environments as well.
No, that makes sense. Like in terms of where we as AWS are, right? We definitely try and provide customers with the right visibility, right? So that you do have full confidence, and that's why partners such as Datadog are super helpful for our customers to make sure that they're fully confident in what they're running.
All right, thank you for that. Our next question reads, what are the top integrations with Datadog that are the most beneficial for DevOps?
So that is a loaded question. I can tell you that integrations can span, and I think that's also like, it would be helpful to know what kind of integrations you're referring to. But so we have integrations both from like the AWS side. So in terms of like what service you're using, we have web integrations. So like any sort of third-party SaaS provider that you might be using. So we have like integrations on the telemetry side, but then we also have integrations on the workflow side. So how you monitor your data, how that data is being alerted on for your users. So for example, one really common integration pattern that a lot of our developers use is, PagerDuty plus Datadog plus Slack and Jira to kind of help augment your process for monitoring. We highly suggest, and all of these allow templates for you to kind of jump right into the relevant data that you're monitoring your AWS services with. And then Datadog does a lot of the work to integrate with the AWS console. So, from Datadog, you can also jump into the AWS console and help your developers start their troubleshooting journey. So I know that was a pretty high level answer, but I can drop in a link to show all of our telemetry integrations as well as our SaaS integrations for workflows.
All right, so diving right into our next question, how can I leverage Datadog Agent to support RDS proxy and report latency response for large query?
That is a good question. It doesn't fall. This one will be something that I believe might be solved by our database monitoring product. I strongly urge you to check that out. So we do, for select databases, show in a full trace end to end what might be causing latency and also what slow queries might be occurring. One thing I will have to double check on whether is that works for RDS. So I will be dropping in that link along with the integrations links. Oh, Cody, I think you're muted.
You are right. So moving into our next question, how do Java apps with Snap Start compared to Node.js or Python?
Yeah, I can take that one. again, I think application performance and startup performance of functions depends on customers' code and varies on a case-by-case basis. What I can say is Java functions with SnapStart enabled, generally on average, what we see is comparable performance to what traditionally are kind of more performant languages like Python and Node over there. So we definitely see that customers get similar or better performance characteristics for startup behavior with Java functions with SnapStart.
All right, and this looks to be our final question that we've received so far. So last call for any questions if you'd like to send them in. And this comes from Jay. Do you have a cross-cloud aggregation feature? Basically tie traces from site on Azure that uses an API gateway and get a round trip detail.
Do you mind repeating that question, Cody? I'm trying to find it here on the chat. I just want to make sure I'm understanding it correctly.
Yes, and I believe this one might be for Maxime. I think this might have been from our demo session that we're bringing back over into here, being re-asked. So it was referencing Maxime's AWS and Azure tabs within the demo environment. Do you have a cross-cloud aggregation feature, basically that ties traces from a site on Azure that uses an API gateway API and get a round-trip detail?
That's a good question. I'm not sure we have full capability of doing that, but if we're using OpenTelemetry and respecting the headers sent by OpenTelemetry, we should be able to build a full end-to-end traces. It really depends on the service you're using and how you instrument everything. So if you're respecting OpenTelemetry, yeah, it should work.
Awesome. So a couple more questions have continued coming in. So thank you everyone for sending those. Does Datadog agent use X-ray at some point or not?
That's a good question. I can take that one. So we have two approaches to tracing. One that we have bundled in with our extension for Lambda specifically is to use the Datadog tracing library, which will actually auto-instrument using Datadog's, tracing libraries that run in even host-based environments. So that is one way to trace your applications. On the other hand, for things like AppSync and Lambda and step functions, you also have the ability to use X-ray tracing, and it's only isolated to those three services. So that integration is also available for you to use. And instead of us tracing, by us, I mean Datadog, but instead of Datadog creating the traces, we'll just pull in the traces from X-ray. We also have the ability to integrate X-ray traces with our own tracing. So you can actually enable that as well, and it'll join any, for example, if you have Datadog tracing enabled on Lambda, and then you are, invoking AppSync, you can kind of merge X-ray traces into a trace as well, using both approaches.
Great. Well, just in the interest of time, I'm going to wrap us up with this final question coming from Nick G. Is there a straightforward way to get application logs, metrics, and analytics for ECS deployed via Fargate?
There a straightforward message. Can I ask about what sorts of I guess so is the question, sorry, if you wouldn't mind putting the text up. Sorry, there we go, perfect. Application logs, metrics, and analytics, right? So ECS definitely vends application logs, metrics, analytics, right? And so we have those vending of the metrics. So if you're using something like a Datadog agent with Fargate, then all of those metrics, logs, and analytics are ingested by Datadog, and they just expose into your account, right? So unless I'm kind of misunderstanding the question, but generally speaking, right, we vend our own internal telemetry, right, and we emit them as APIs, right? And so something like Datadog comes in and will just collect the information and display it for you. Hopefully I got the question right. I think that's what the question is going for. So, but so we do then because you don't necessarily have access to the underlying host. So there are things that we actually go in and pull out, and we would vend as an API for you.
All right, Steve, I think you hit it because Nick says thank you in the chat. Awesome. So I think we can wrap up our Q&A section here. Sumita, did we have any other closing slides we wanted to run through before we start wrapping things up? I know we need to get that QR code up on the screen.
Yeah, so there is a QR code on the screen. So you can get started with a 14-day Datadog serverless free trial. Datadog also has a public Slack channel, so I know there were a few other questions coming in. So I can link that in the chat as well. But if there's any other questions, we have a channel for just serverless. We have our engineers such as Max always looking to answer anyone's open questions. So I appreciate everyone's time. I think it was a great discussion and great questions as well. So thank you so much for coming, and I hope everyone has a great rest of their day.
Thanks, everyone.
Thank you.
Thanks.
All right, so before I officially dismiss everyone, don't click out just yet. I've got a couple of closing remarks. So of those of you who will click on this QR code and sign up for a 14-day trial, one lucky winner will be selected to receive a limited edition Datadog backpack. So that's why we're leaving this QR code up there to give you the chance to sign up if you have not already. You don't want to miss out on the 14 days of free trial. So just a couple of final reminders. Our session today was recorded. Following this program, you will receive an email with a link to access the recording on demand, or you can find this living on the DevOps website at devops.com/webinars, and it will be in the on-demand section. We will be reaching out to two of our most engaged attendees today, whether that was chat, Q&A, or filling out our post-webinar survey. And we'll be selecting 2 people to win a $50 Amazon gift card. So thank you so much for your participation today. And it is not too late to fill out that survey to qualify. Additionally, I would like to thank AWS and Datadog for sponsoring our program today. And to everyone who is here with us, even though we've gone over a couple minutes, thank you so much for your time. We appreciate you joining us here on Techstrong Learning, and we hope to see you at a future Techstrong Learning experience. Have a great rest of your day, and you may now disconnect. Thanks again to everyone in our panel.